Hello all. Today we'll see the third type of finding the YC, that is the method of variation of parameters. Already we have studied the uh, two methods to find the YC of linear differential equation with constant coefficient. First was the general method, second is the shortcut method, and third one is the method of variation of parameters. So method of variation of parameters is used for the second order differential equation. So it can be used for the cubic or 4 power or differential equation. So let's assume some differential equation. Suppose you are having some linear differential equation of second order a d2y by dx square plus b dy by dx plus cy is equals to x. So capital X is some function of x on right hand side. So let's assume that we know that it will have two roots. If two roots are there, its yc will have two constants. So suppose constants are c1 and c2. So let's assume yc is equals to c1 into y1 plus c2 into y2. So you know very well c1 is the constant, along with that you will have some function. So it will depend on the nature of roots. If roots are real and distinct, you will have c1 e raised to something plus c2 e raised to something. If roots are real and repeated, you will have, depending on how many times it's repeated, c1x plus c2, like that. You know very well. The same, some rules are there for the imaginary numbers as well when the roots are imaginary. So you can calculate yc by your regular way. So here, whatever along with constant c1 is there, that is nothing but y1, and along with c2 you will have y2. Now let's assume that for this yp is equals to uy1 plus vy2. Now y1 you will get from yc. So these two y1s are same. These two y2s are same. So y2 and y1 you are going to get from yc itself. Now to find the yp, you need to find u and v, so that you can find, you can add yc and yp and you will get the complete solution. So here the formula for y1 is that it is minus integration of y2 capital X means right hand side function upon w dx, and for y2, sorry, it should be u, and to find v you have y1 capital X upon w dx. So in this way you can find the u and v, put the value of u and v here along with y1 and y2, and you will get the yp. So in this case you can observe here that w is there. So w is nothing but determinant of y1, y2, y1 dash and y2 dash. So y1, y2 already we got it from yc. Let's take its derivative and you can find the w's value. You can put the value of w in finding the u and v. So let's assume some example. Suppose you are having the linear differential equation with constant coefficient like this. D2y by dx square plus y is equal to cosec x. So as usual, we know that first step is to convert it in terms of d. So this is d square plus 1 y is equals to cosec x. What will be auxiliary equation of this? So auxiliary equation is d square plus 1 is equals to 0. So roots are d square is equals to minus 1. Therefore, d is equals to plus or minus iota or I. Imaginary it is. So by the rule number 3, yc is equals to, how many constant its solution should have? 2, as we are having two roots. It will be c1 cos x plus c2 sin x. Now this, as I said, ki whatever is there along with c1 is your y1. So what is y1? y1 is cos x. And whatever along with c2 is there, that is nothing but y2. So y2 is sin x. Then as you know the value of y1, y2, let's assume that yp is equals to uy1 plus vy2. So y1, y2's value we know very well. Let's find the value of u and v. Once you will get value of u and v using these two formulas, you can get the yp for this. So to get the u and v's value, firstly you need to calculate w. So w is equals to y1, that is cos x, y2 is sin x. What is derivative of cos x? It's minus sin x. And derivative of sin x is cos x. You know very well how to find the determinant. Cross multiplication, cos into cos will be cos square x minus sin into sin square x along with negative sign. So minus minus becomes plus. So it is sin square x. And you know very well sin square plus cos square is always 1. So we got w as 1 in this case. Once you get the value of w, let's find u. U is equals to minus integration of y2 x upon w dx. So this is equal to, let's put the values. Y2 is sin x, capital X is cosec x, and upon w is 1 and dx. So this is equal to, you know very well, this is negative sin x into cos sin x into cosec is nothing but 1 upon sin x dx. So this sin x will get cancelled. You will have minus 1 dx. And what is integration of minus 1? So minus 1's integration is x. So it is minus x. This is value of u. Now once you get the value of u, let's find the value of v using the formula y1x upon w dx. So what is y1? y1 is here cos x, capital X cosec x upon w is 1 and into dx. So this is equal to integration of cos x. Cos x is cos x. Let's write cos x. And cosec x you can write it as 1 upon sin x. So cos upon sin is cot x. Integration of cot x is log of sin x. So in this way you got the value of v as well. Let's put the value of u and v in this formula. So yp is equals to uy1. U is minus x, y1 is cos x, y2, vy2. V is log of sin x and y2 is simply sin x. You got the value of yp. Then finally write complete solution is y equals to yc plus yp. Add them. So from equation number 1 you will get yc. From equation number 2 you will get yp, and add them you will get the complete solution. So in this way you can solve any kind of differential equation. Just make sure that it should be of second order. Then only you will be able to use the method of variation of parameters. Hope you got this example. Thank you all of you.